Gateway Load Balancing Protocol, GLBP. How is it different than HSRP and VRRP? Well, with HSRP and VRRP, we have one device forwarding traffic for the virtual IP address. However, with GLBP, we can have up to 4 devices forwarding traffic for that virtual IP address. So it provides true load balancing. Well, it might not be perfect at 100% load balancing, but it's pretty close. So if you want to call it load sharing, you can. But essentially, we're allowing up to 4 devices to act as a forwarder for that virtual IP address, all at the exact same time. So while we're troubleshooting GLBP, what are the types of issues that we should keep in mind? Well, number one, those 4 routers have to be part of the same GLBP group. So the group number has to match. In addition to that, since they are responsible for that default gateway IP address, all 4 of them, that virtual IP address that is being used has to match on all 4 routers in the GLBP group. If you're using authentication, the parameters have to match. Why? Well, anytime you authenticate, the parameters have to match. It's that simple. If there's a mismatch in the parameters, then those routers don't classify themselves as being part of the same group. They won't accept and process the hello packets that are received by each other. So those parameters have to match. Preemption. Now, preemption is enabled and disabled. What do I mean by that? Well, for the AVG, the Active Virtual Gateway, preemption is disabled by default. So if you want to control who the AVG is, you want to make sure it has the highest priority, and you want to make sure that preemption is enabled. It's just like HSRP and VRRP. If you want to control who the forwarder is, the active forwarder is, in both those cases, you give it a higher priority and you enable preemption. Now, VRRP, it's enabled by default. But with GLBP, you have to elect an AVG, the overseer of the GLBP group. And the priority and the preemption is used for that process. And preemption is disabled by default. So you want to make sure that the AVG has the highest priority and preemption enabled if you want to control who that is. What about the clients? Well, the client needs the correct virtual IP address configured as its default gateway. If it's pointing to the wrong IP address, then the client is not going to be able to successfully communicate out of its subnet. And lastly, we can do object tracking with GLBP, just like we could do with HSRP and VRRP. But here's something I want you to realize. With object tracking with GLBP, it's not for the AVG. It's not for the AVG at all. Let me draw you a picture here. We're going to just put 2 routers in our group. That's it, just 2 of them. All right. Now, what I want you to realize here is that right now, this router is going to be the AVG. And this is simply the standby AVG right here on the right-hand side. If this link fails or this link fails, this device automatically becomes the AVG. Not a problem at all. If this link fails, is it necessary for this device to become the AVG? No, it's not necessary at all. This device can remain the AVG, even if this link fails. So object tracking is not necessary for the AVG. What object tracking is necessary for is the AVFs, the active virtual forwarders. Why? Well, do I want this to be an active virtual forwarder if this link fails? No, not at all. Not at all. Because if the clients send traffic to that AVF, it gets dropped because it can't forward the traffic on. So object tracking is for the AVFs, the active virtual forwarders. And we have the ability to decrement the weighting. Whoa, there's a new term if you're not familiar with it. The weighting of the AVF. So if we have a weighting configured, let's say on this AVF of 105, the default's 100, just like priority is defaulted to 100, weighting defaults to 100. And this device we have a weighting of, let's say, 95. Right now, our router on the left is the AVF for MAC address 1. And our router on the right is AVF for MAC address 2. So we'll call them AVF1 and AVF2, forwarder 1 and forwarder 2. What we can do is we can set up object tracking that states, if this interface goes down, decrement your priority, let's say by 50. And as a result, your new priority becomes 55. If this value is less than a threshold that's been specified, so it's lower than this lower threshold we specify, you no longer are the AVF. And as a result, this device over here now has to become the AVF for MAC address 1 and MAC address 2. So it works perfectly. We can control which AVF or which router is going to be the AVF for a MAC address based on the conditions within our network. So this is known as object tracking, but instead of it being for the priority, like we see with HSRP and VRP, it's for the weighting of the active virtual forwarder. So if all of a sudden you're experiencing an issue where this device is forwarding for all of the MAC addresses, double check to make sure that object tracking has not been triggered, and as a result an interface has been down, and you have problems with your uplinks. That might be the issue. Or maybe somebody accidentally shut down the interface, and as a result, we had to have this device take over as the active virtual forwarder. So here's an excellent GLBP configuration that you should be able to read and walk through. And you might be saying, well, why do I care about the configuration? Won't I be using commands like show GLBP or show GLBP brief? Yeah, you will be. But however, spotting the difference comes in handy when you're troubleshooting HSRP, VRP, and GLBP. Why do I say that? Well, let's say you have 4 GLBP members within your group. So 4 active virtual forwarders. And you're troubleshooting an issue. Something's going wrong with one of them, or even 2 of them. So you pull up the configs side by side, all 4 of them, and you start comparing. Is this virtual IP address correct? Yes or no? It has to be consistent across all of them. What about this right here? The group numbers. That group number is going to have to match between all of them. Not only that, it has to match within this configuration as well. If you accidentally make a typo and you type in 11 or 10, that's a big problem because that configuration no longer applies to that particular group. It applies to the group, that number you specified right there. So using that method of troubleshooting whereby you spot the difference comes in handy when you're troubleshooting the first hop redundancy protocols. In addition to that, you can therefore verify that the timers are accurate. You can verify that authentication matches by spotting the difference. So looking at this output and being able to read it and understand what's going on is going to come in handy. Not only that, when you're doing your object tracking and you are identifying why an AVF within the group is forwarding for multiple MAC addresses, you can see that right here. You can see exactly what's going on. Here's the configuration that was utilized for the tracking objects. The tracking objects are the fast Ethernet interfaces of /24 and /23, and all we are is tracking the status. Is it up? Is it down? If it's down, we're going to perform an action on it. If it's up, just leave it alone. So what's the action we're performing? We're decrementing. So here's the tracking object for 90. We're going to decrement by 10. Here's the tracking object for 91. We're going to decrement by 20. But what are we decrementing? We're decrementing the weighting value. Remember, with GLBP, object tracking is for the AVFs, not the AVG. So the weighting is right here. By default, the weighting is 100. But it's been modified here to 110. So this is the initial value of the weighting. And this lower threshold says if your weighting gets decremented to 85 or lower, you can no longer be the AVF. You can't be the AVF because you no longer are good enough to be the AVF. So if we look at this example, 110, if interface fast Ethernet 0/24 goes down, we decrement by 10. Now our weighting is 100. Are we still allowed to be the AVF? You bet we are because we haven't surpassed 85. We're good. But what if now all of a sudden fast Ethernet 0/23 goes down? That means decrement by another 20. So 110 minus 10 was 100. Now 100 minus 20 is 80. So what does that mean for us right here? It means we have breached 85. We're lower than it. We can no longer be the AVF, so we will not be the AVF. So what's this upper threshold for? It's for the way back up. So as we start re-enabling interfaces, let's re-enable interface fast Ethernet 0/24. What does that do for us? Well, the tracking object comes back up. We are now going to increase the weighting by 10. So we were at 80, now we're at 90. Is that good enough to resume the role of AVF for a MAC address? No, it's not, because according to this upper threshold, we have to be at 105. All of a sudden, we re-enable 0/23. Add 20 more onto 100, or 90, And so 90 plus 20 is 110. We're now at 110. We have surpassed 105. We can now be the AVF for the MAC address. So having the ability to read this output, having the ability to verify and spot the differences amongst the other routers is going to be very, very powerful as you are troubleshooting GLBP.